In stoichiometry, we use the balanced chemical equation to figure out about different mass relationships in a reaction. In general, you can think about it, the process or what you need to do this way. You'll be given some information about one of the components in the reaction. It can be a reactant or a product, and you'll either be given it in units of grams, so you might know about the grams of one of the components, or you might know about the moles of one of the components. And then you'll be asked to find about one of the other components. And they'll usually ask you, or they will ask you, to find it in moles of the new thing, or they can ask you in grams. Now, in order to go between these different units, to go from moles of one substance to moles of another in a chemical equation, to go from here to here, we use the mole ratio that we can determine using the coefficients in the balanced equation. And in every stoichiometry, that ratio is used. Now, the ratio has to be in moles. So if you're given grams, you have to use the molecular weight or the molar mass to go from grams to moles. And if you're asked to find grams, you will also have to use the molecular weight of that substance to go from moles to grams. So it's this basic process. If you are given grams of one substance and asked to find grams of another, you will require 3 different steps. So let's go ahead and take a look at our problem, see what kind of questions we can answer from this. So in this question, we're given 27 grams of copper reacts with 127 grams of nitric acid, and we're trying to find the grams of copper 2 nitrate. So look here, we're going from units of grams to grams, so it's going to take 3 steps. Now this is a limiting reactant problem, and how I know is that I have 2 reactants, copper and nitric acid, and they've told me amounts of both. So what I know is that one of them will most likely get used up before the other. I suppose there could be some rare circumstance when you have exactly the right amount of both, so they get used up at the same time. But usually one is limiting, which means it gets used up first, and the other one's in excess. So we have to figure out which one is going to get used up first. And there's a variety of ways to do this. I'm going to start by figuring out how much copper 2 nitrate the copper can make, and then comparing it to how much copper 2 nitrate the nitric acid can make. So I'm going to start with 27.5 grams of copper. The first step is to convert it to moles using the molecular weight. And I have above on the balanced equation, I looked up and wrote down the molar masses before we started. The second step would be to use the ratio between the 2 substances. So I see a copper nitrate is a 3 and the copper is a 3. That's basically a 1-to-1 reaction. It is a 1-to-1 reaction. So you wouldn't necessarily have to write it. Whoops, I don't like what I did there. Like how I wrote it, because I didn't put in moles, and I like to include moles because it is a mole ratio and it helps it be clearer to me. So it is a 1-to-1 ratio, so it's not going to change the number. And then to convert into grams of copper 2 nitrate, I have to multiply by its molar mass, which again I calculated before we started. Can't quite write copper nitrate behind it. All right, so I will calculate the answer here. So I calculate from 27.5 grams of copper that I would expect to get 81 I'm going to go to 3 significant figures, 2 grams of the copper 2 nitrate. So now I'm going to compare that, though they also told me I had 125 grams of nitric acid. And so I want to find out, well, how many grams would that make? So again, the molar mass of the nitric acid, that's what this is. I calculated this before I set up the problem. And then I need the ratio. Well, again, it's going to be, it's going to have a 1, a 3 on top, and an 8 on the bottom. So it's going to be 3 moles of the copper nitrate over 8 moles of the nitric acid. And then to convert it into grams of copper nitrate, I'll multiply it by the molar mass of copper nitrate. So now let's calculate this. So plugging it in, calculating how many grams 125 grams of nitric acid is, I get 139.5 grams. Well, it would really be, I guess, 140. But looking at the two answers, so now what I do for limiting reactant is you compare the two answers. So I look, this, the 27.5 grams copper gave me 81, and the 125 nitric acid gave me 139. So how much I think it will be made, you'll always choose the smaller amount. And we'll always choose that one. And this number basically is not part of the answer. The only reason I had to calculate it was to be able to compare the two reactants. So the answer is 81.2 grams of copper nitrate. And to identify, the copper here in this example is the limiting reactant. And the nitric, and it would get all completely used up. And then the nitric acid, there would be some remaining, and this is what we call our excess reactant. So let's look at the next question that has to do with this particular reaction. So letter B says, how many grams of the excess reactant remains? Okay, well, I need to gather. There's several, again, ways to do this, and I'll tell you how I think about it. I take whatever the limiting reactant is, and I ask myself the question, how much of the excess reactant is needed? So let me go back to the previous page. And I said the 27.5 grams of copper was the limiting reactant. And so what I'm going to ask myself is how much of the nitric acid reacts with that. So I want to remember 27.5. Okay, so 27.5 grams of copper. This is the limiting reactant. And I want to know how much of the excess reactant is going to react with it. So first I have to convert it into moles by dividing by the molar mass of copper. Then now the ratio, I want to know how much of the other reactant, nitric acid. So when I look up here, this is an 8 and that's a 3. That's the two I'm looking at. So I say 8 moles of nitric acid reacts 3 moles of copper. And now to figure out how many grams of nitric acid there are, I'm going to multiply by the molar mass of nitric acid. So doing this problem, let's calculate the moles that we need. I didn't mean moles, I meant grams. And so calculating this out, if you follow your units, that's what it should be. I get 72.7 grams of HNO3. And this is not what's left. This is what is used. Okay, so let me go back. I got to remind myself how much. I think I had 125 grams. Yes, I started with 125 grams of nitric acid. So if I started with 125 grams of nitric acid, so this is what I started with. And then I used 72.7 grams. And then if I subtract those two numbers, minus 72.7, I would get 52.3 grams of HNO3 is remaining. And I guess if I'm doing significant figures, since it's subtracting, I probably could just write 52 grams since I only had 125 to start with. So about 52 grams of the nitric acid remains. So you see what I did there? We had to figure out how much excess remains. We had to do one more stoichiometry problem to figure out how much of the excess was used, and then we could subtract it. Now the final question has something to do with percent yield, and the equation of percent yield would percent yield equals the actual yield divided by the theoretical yield times 100. So first, just looking at the definitions, the actual yield, this is what you get, this is produced in the lab. Okay, the theoretical yield down here, this is what we've been calculating. This is from the balanced equation. This is calculated. Okay. So this problem asked us, it gave us the percent, and we're going to look on a previous problem and see what did we calculate our theoretical yield. I'm going to go back. Our theoretical yield is right here. It's 82.1 grams, okay? Oh, 81.2, sorry, 81.2. So our theoretical yield we calculated from our previous in step A, and we calculate it to be 81.2 grams of the copper 2 nitrate. Okay, so now we the problem says if the percent yield, which here is the equation for percent yield. So looking at it, let's see what I know from this equation. I kind of like to start that way. I know it says if the percent yield of copper nitrate is 87.3, so I know this number. What is the actual yield in grams? Well, I know the theoretical yield. So the actual is my X. I don't know it. So let's see. I say 87.3 equals the actual yield, X, divided by 81.2 grams, because that's what I calculated in part A as my theoretical yield, and then it's times 100. Okay, so I could say 81.2, I'm going to multiply the 81.2 over to the left side, times 87.3. And I get a 7088.76 grams equals X times 100. And now I'm going to divide by 100 onto the left-hand side to get X by itself. And I get 70.88, so 76. So I guess to three significant figures, I get 70.9 grams. So my actual yield would be 70.9 grams. This is two steps. 70.9 grams. So you see what I did? They told me the percent yield, which 87.3. I calculated from part A the theoretical yield to be 81.2 grams. I'm solving for X, that's my actual yield, and don't forget it's times 100 over here. So using algebra to solve for X, I got that my actual yield and the answer to this question is 70.9 grams.